When you write code in programming languages like Python or C++, your computer cannot understand it directly. Computers only understand machine language, which is made up of zeros and ones. To bridge this gap, we use two special tools called compilers and interpreters. Both of these tools convert your human-readable code into machine code that computers can execute. Today, we'll explore how these two approaches work and what makes them different from each other. Let's start with the basics. A compiler is a program that takes your entire source code and translates it into machine code all at once, before the program runs. Think of it like translating an entire book from one language to another before anyone reads it. On the other hand, an interpreter works differently. It reads your code line by line, translates each line into machine code, and executes it immediately. It's like having a translator who converts sentences one at a time as you speak them. The compiler follows a specific process. First, it reads your entire source code file from start to finish. Then, it analyzes and converts all of that code into machine language in one go. Finally, it creates a separate executable file that contains the machine code. This executable file can be run multiple times without needing the original source code. Once the compilation is done, you can distribute this executable file to other computers and run your program without compiling it again. Interpreters take a different approach to executing code. Instead of processing everything at once, an interpreter reads your code one line at a time. As soon as it reads a line, it translates that specific line into machine code and executes it immediately before moving to the next line. This means the translation and execution happens simultaneously. Unlike compilers, interpreters don't create a separate executable file. Every time you want to run your program, the interpreter must go through this line-by-line translation process again. Both approaches have their own benefits. Compiled programs run much faster because the translation work is already done. The compiler also optimizes the code during compilation, making it more efficient. Additionally, compiled programs offer better security since you only distribute the machine code, not your original source code. Interpreted languages, however, make debugging much easier because errors are caught and reported immediately as the interpreter encounters them. They're also platform independent, meaning the same code can run on different operating systems. Finally, there's no waiting time for compilation, so you can test your code changes instantly. Of course, each approach also has drawbacks. With compilers, the development cycle is slower because you must recompile the entire program every time you make a change. Debugging is harder because all errors are reported together after the entire compilation process. The compiled code is also platform dependent, meaning you need different executables for Windows, Mac, and Linux. For interpreters, the main disadvantage is slower execution speed since translation happens during runtime. Your source code must always be available to run the program, which can be a security concern. Finally, interpreters perform less optimization compared to compilers, resulting in less efficient code execution. Let's look at some real programming languages to understand this better. Languages like C, C++, Rust, and Go are compiled languages. When you write code in these languages, you must compile it first to create an executable file. On the interpreter side, we have languages like Python, JavaScript, and Ruby. These languages are executed line by their respective interpreters. It's worth noting that some modern languages blur the line between these categories. For example, Java uses a combination of both compilation and interpretation to achieve the best of both worlds. Here's the most important thing to remember. Both compilers and interpreters serve the same fundamental purpose. They translate your high-level programming code into machine language that computers can understand. The key difference is when this translation happens. Compilers do all the translation work before your program runs, creating a fast, executable file. Interpreters translate the code during execution, processing it line by line as the program runs. Understanding this distinction will help you choose the right tool for your programming projects and appreciate why different languages behave the way they do.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.